Hello viewers, welcome to Big Boy Physics, and in today's video our target is to cover integration. Today's video I'll be explaining you the what is integration and the formulas. In the next video I'll be taking up some examples and application of integrals. Okay, so let's get started. Now what is integration? You might have heard various definitions that it's the algebraic sum of areas of a function. Okay, it's not exactly the sum of areas of the function, it's called the algebraic areas of the functions. Or also you might have heard that it's the reverse process of differentiation, not to be suppressed. This is also called the reverse process of differentiation. Okay, in differentiation what is the use? It is to find the slope, and in integration it is to calculate the algebraic areas. Okay, so let us see some examples. Let me take the general x and y system and consider the curve y is equals to x, y equals to mx, suppose. Okay, I am taking a line y equal to mx, right? Just a minute. Yeah, so this is my y equal to mx. I don't know what happened. Suppose this is the curve y equal to mx, and this angle theta, tan theta, is equals to m. Now if you are told to find the area between somewhat x1, from x1 where x1 lies on the positive x-axis and x2 which lies on the positive y-axis, then can you tell me the area between these two regions, that is I'm marking with blue color, that is this shaded region. So this area is given as x2 minus x1 into, what is this height, mx2, and this height is mx1. You can write it mx2 minus mx1 by 2, right? If you try to find this area, 1 minute, it will come out to be mx2 plus mx1. We know that it's the area is distance between the parallel side into sum of the parallel lengths by 2. So it will come out to be m x2 square minus x1 square by 2, right? Hope you get it. So this is the case when x2 is greater than x1. Even if x1 is greater than x2, that doesn't matter because the sign will just change and all those things will happen. Now suppose in the second case, I am considering another point x3. Suppose here it's x3 and x3 is lying on the negative x-axis. I have to find the yellow region. Suppose from x3 to x1. So area can be written as m x1 into x1 by 2 plus mod mx3 into x3 by third, right? If you want to find this magnitude summation of the areas, then we will be doing like this. But observe that this region is actually downward of the x-axis. If you observe this region, it is below the x-axis. That is why we get a minus sign with it. We get a minus sign because in integration we try to find the algebraic sum. While denoting the algebraic sum, we mean to say that the downward regions are considered negative and the upward regions are considered to be positive. This is the meaning of the algebraic sum. Hence, if you do the integration, you will get it to be m x1 square minus x3 square by 2. Sorry, it will be 2 here. Okay. So integration is basically the algebraic summation of the area. Rather than saying it is summation of the areas, we say it to be algebraic summation. Okay. Now how to derive the general formula for integration of y equal to mx? Let us see. What we do is, again we consider a coordinate axis and we consider this line y equal to mx. Just a minute. Yeah. So this is my line y equal to mx. This is x-axis and this is y-axis. To find the area, we do one thing is that we take a small rectangular strip. Okay, suppose we need to find the area from 0 to x1. 0 to x1. We or suppose it to be x naught. We divide this section into a large number of thin rectangular strips of thickness or width, you can say h. Okay, then let us say capital N into h is equals to x naught. Hence we can say that h is equals to x naught by n. Now what will be the differential area? What will be the small area of this thin strip? This way denote it as delta A can be written as h into f of h. F of h is the height of this barrier and f of h is mh. So I can write it to be mh. So we can say that the area of one strip is h into, it will, if this is the nth strip, apologize, if this is the nth strip, then I can say this to be nh. If this is the nth strip, then I can say this to be nh. So my height will be m into nh, not m into h, because we are dealing with the x coordinate and h is the thickness of the strip. So the area will be coming to be m into h square into n, right? If you find the summation of areas, the total area delta A will come out to be mn into h square summation, where summation is done on the n variable from n equals to 0 to capital N. So taking the constants out, I'll get m into h square summation of n, that is 0 plus 1 plus 2 plus 3 up to n, will come out to be capital N into capital N plus 1 by 2. Now observe that n is very large. So I can say n is so large that it's much greater than 1. So capital N, putting it to be x naught by h, I can say one thing, that n plus 1 is nearly equal to n. So the answer will come out to be m into hn whole square by 2. And we already derived nh is equal to x naught. So I'll get it to be m x naught square by 2. And that's the integration. What we say, that integral, in other words we say that integral of mx dx, observe that is mnh, I have substituted it as mx, and this h I have kept it as dx, and the summation is replaced by this snake like symbol or the s like symbol, which is called the integral. So we say that integration of mx dx is equal to mx square by 2 plus c, but c depends on the initial conditions. Suppose I may take the area from x1 to x 0, then we have to substitute accordingly the values. That is why the area from 0 to x1 we actually denote it by c, and we adjust the value of c so that this area from x1 to x 0 can be found accordingly. Okay, I hope you get till this now. Now coming to the next portion. Next, I'll be taking another example. You might have thought this is a very simple one. We can just find it manually using geometry. Let me take another example. Y is equals to x square. Consider this graph, and this is the parabola I need. I need to find the area of this parabola bounded by x-axis and itself between x is equals to 0 and x is equals to x naught. Suppose, right? Again, we consider capital N strips. Capital N into h is equals to x naught. The same thing we are committing here. Now considering the nth strip, this is of with h, and the height will be n square h square. So differential area can be written as n square h square into h, which can be written as n square h cube. Okay. Now if you take the summation again, we can just denote it by integral of, what is n square h square? N square h square can be written as x square, and h is dx. So what we do here is just taking the summation, and we'll get capital N into capital N plus 1 into 2n plus 1 by 6 into h cube. The same thing we are doing it here again, that putting n to be so large that n plus 1 is equals to n and 2n plus 1 is equals to 2n. So I'll get it to be x cube by third. So I can say that integral of x square dx is equals to x cube by third plus c. Hope you get it. So yeah, that's the answer. And from here we'll get a general formula. We'll be learning a general formula. That is, for any curve of form y is equals to x to the power n or kx to the power n, we say that integration of kx to the power n dx is equals to k into x to the power n plus 1 upon n plus 1 plus c for all n belongs to real numbers except n equal to minus 1. So I can say that for all real numbers n, I'll get the integration of kx to the power n as kx to the power n plus 1 by n plus 1 plus c for all n belongs to real number except n equals to minus 1. Okay, I hope you get it. Now coming to the next portion, suppose let's take some examples. Example is integral of x to the power 9. Integral of x to the power 9 can be written as x to the power 10 by 10. Integration of x to the power 3 by 2 can be written as x to the power 5 by 2. Whole divided by 5 by 2, you will get it to be 2 by 5 x to the power 5 by 2. Now coming another problem is x to the power minus 7 dx is equals to x to the power minus 6 by minus 6. Fourth problem, integral of 6 dx. Now this is a trap because it's the same as the previous one. You can write it as 6x to the power 0 integral. Hence you'll get 6 into x to the power 0 plus 1 upon 0 plus 1, which will get to be 6x. Now, yeah, of course there will be plus c by default because we are doing indefinite integrations. While we reach the end, we'll be talking about definite integration also. But for now, they assume that I may have missed the c out, but there will be c in default. If I miss a c at the end, you can assume that there will be a c in default. Okay. Now you will be thinking about what will be integration of x to the power minus 1 dx. You mean most of you might have learned about it. It's written as ln x plus c. Okay, just remember this formula: integral of x to the power minus 1 dx equals to ln x plus c. Even if you see the differentiation of ln x, it comes out to be 1 by x. So since d by dx of ln x is equals to 1 by x, and we know that integration is the reverse sign of differentiation, think it in this way. Think it like this: you can put it ln xc plus ln x because differentiation of c with respect to x is 0 where c is a constant. C belongs to a real number. Multiply both sides with dx. You'll get d of c plus ln x is equals to dx by x and integrate it. This integration sign basically cancels a d if it's independent, so you'll get it to be c plus ln x, and that's the way we prove the integration of 1 by x dx. Yeah, we can use the strip method also, but I favor this method for integration of ln 1 by x. Now let us see some examples or some formulas. So few formulas we'll be learning about. First is, if you have two functions, u as a function of x and v as a function of x, then this integration of u as a function of x plus v as a function of x plus minus, better to say plus minus, v as a function of x dx is written as integration of u as a function of x dx plus minus integration of v as a function of x dx. So if you put a plus in the between, it will come out to be plus. If you put a minus in the between, it will come out to be minus. If you put a plus minus, it will come out to be plus minus. Means it will be in a definite order. The sign will not get reversed or converted into product or division. The operator will be defined. But one thing you must remember, that integration of ux into vx dx cannot be written as integration of ux dx into integration of vx dx. Okay, or for division also we cannot write it like this. We have a more detailed and difficult formula for it, or rather say lengthier formula. We say that integral of ux into vx dx can be written as ux into integral of vx minus, okay, and the dx also is there, minus, this is the first part, and the second part is integration of differentiation of u with respect to x into integration of the Vx. Now this is in with the dx and the whole is integrated with the dx. First we'll be talking about the integration of this, then we'll be differentiating this, then we multiply both of them and then integrate with respect to x. And of course not forgetting a plus c, that is by default. Now observe one thing you must remember, that when this integration is done, it does not comes out like some capital Vx plus c. We only write it to be capital Vx. We do not write the c in this part. Okay, you must remember that we when we do the indefinite integration of this Vx, we do not consider any plus c or something. What we do is we actually put the whole integral, and while doing the definite one, we put the limits. Okay, I hope you get this till this now. And coming to now for some formulas to remember. First, I've already discussed is that integral of c times u of x dx can be written as c times integral ux dx. We basically increase the height by a factor of c. So that is why we are multiplying the integration with a factor of c also. Second, now coming to few formulas. First is integral of cos x dx is equals to sin x plus c. Third is integral of sin x dx is equals to minus cos x plus c. Fourth is now coming to fourth formula. Fourth formula is a little interesting. That integral of e to the power x dx is equals to e to the power x dx. Even in differentiation, you might have seen that the differentiation of e to the power x is e to the power x, and so the integration of e to the power x is also e to the power x. Coming to fifth formula is a theorem, that is integral of f of ax. If you put f of ax, then integral of f of ax with respect to dx, it can be written as 1 by a times integral of f of x. This is capital F of x, where f of x, where integral of f of x dx is written as capital F of x. Okay, so this is a theorem. You might not understand it clearly now, but I'll be explaining you with a few examples. Suppose you have an example like integration of e to the power x dx is equals to e to the power x. I'm not writing the plus c just for convenience. We adjusted with not writing plus c in case of physics for now. In mathematics you may need it, but in physics don't write plus c for now. Okay. Then we can say that integral of e to the power 2x. What is the integration of e to the power 2x? Just keep the function as it is. E to the power 2x with respect to dx, of course. Keep the function as it is e to the power 2x. Now divide this function by 2 because there is a factor of 2 in the function. It's like f of 2x, and add a c, that is a constant. So coming to some more formulas, before that let us take a question. Find integration of 2 cos x plus 6x square with respect to dx. How to do it? What is just separates the functions. Integral of 2 cos x dx plus integral of 6x square dx. This integration comes out to be 2 sin x plus 2x cube. You can write it as 6x cube by third. Just simplify it to be 2x cube. So you'll get the answer of 2 into sin x plus x cube plus c. Okay. Now coming to more formulas, you must learn some more formulas so to grasp the concept of integration. Another formula you learn is integral of sec square x dx is written as tan x. Observe that the differentiation of tan x is sec square x, so integration of sec square x is written as sec tan x. Similarly, integration of cosec square x dx is written as negative of cot x plus c. Of course, the c could not be forgotten. But in cases if I even miss c, don't mind, because this c does not have much function in physics. Okay, c is just actually used to find the initial values and initial constant. the initial boundary conditions or the final boundary conditions. Okay, so this is the application of C, nothing more. Now you might be seeing some more formulas like let me give you an example. Integral of sec x. This integration of sec x dx is not that much important. Though I am saying you, it will come out to be ln of mod sec x plus tan x. Similarly, you will be seeing more integration like integration of 1 by under root 1 minus x square will come out to be sine inverse x plus c. Okay. Now, the formula till which I have said is actually important for J physics, actually for basic maths physics. Now, rest of the formula you may explore in your mathematics textbooks, or I'll be sharing a screenshot of this whole formulas table in one of the community posts. You may look at it. But till the cos x square x integration, it's enough. You do not need to learn much. Now, taking a few problems. Let me take a few problems. Take a question. Integration of x cube dx. What is integration of x cube dx? It will come out to be x to the power 4 by 4. Second question. Integration of x minus 1 by x dx. What will it come out to be? It will come out to be integration of x dx minus integration of 1 by x dx, just by separating the functions, because the operator in between is actually an plus minus operator. Okay, now separately integrating it, you will get it to be x square by 2 minus what is integration of 1 by x. I said it comes out to be ln x, right, plus c, of course not forgetting a c at the last. For third problem is again one, e to the power 2x plus 1 by x square dx integration, it will come out to be e to the power 2x by 2 minus 1 by x. Integration of 1 by x square can be written as plus x to the power minus 2 plus 1 upon minus 2 plus 1. You will get it to be minus 1 by x. This comes out to be minus 1 by x. Okay. Now coming to a fourth problem. Now this fourth problem is another interesting one. You have to integrate this 1 by 2x plus 3 with respect to dx. One thing I must say you that about this problem, that if you have integration of f of x dx is given as capital F of x, then integration of f of x plus c is written as capital X plus c, f of x plus c. Okay. Similarly, f of ax plus b, where a and b both are constants again. So integration of f of ax plus b with respect to dx with respect to x can be written as f of ax plus b, that is capital F of ax plus b by a plus c. Okay. Now there will be some constants again at the last. The general denotion can be anything. We can denote the constants by beta, gamma, alpha, c, whatever. But try to ensure that it does not coincide with the constant which is given in the parameters, right? Like suppose here it's f of x plus c given in the argument. It will come out to be capital F of x plus c. But if you put the constant to be c, this c actually becomes confusing at later point of time. That is why I replaced it with some gamma. So in this, coming back to the problem, this can be written as f of 2x plus 3. Just integrate it in the usual method. It will come out to be ln 2x plus 3, and the prefactor at the end, which will come out to be 2 plus c, where c is a constant. Similarly, you can try out some more problems. Fourth, like integration of sine 4x plus 3 or cos 4x plus 3. You can comment me below. Take it as a homework problem for now. Okay, we are done with the indefinite integration. Coming to the last property. The last property we'll be learning is substitution. Substitution. Suppose you have a function to integrate like f of g of x into g dash x into dx. How can you put this function in a proper way so that you can integrate it very easily. Do one thing, put gx to be u, and g dash x is basically differentiation of gx with respect to x. Then you can say du to be d by dx of gx into gx into dx, and d by dx of gx can be written as g dash x dx. Hence, you can say integration of f of u du can be written as capital F of u. I am considering the integration in standard format. Capital F of u plus c. Hence, it will come out to be capital F of g of x plus c. Right? Hope you get it. Now, I know that you may not have got it properly because I did just provided what can I say, barefoot proof. I just showed you the formulas and all those. Let us pick up an example. The example is integrate this thing under root 1 plus y square into 2y dy. Okay, this thing is actually this 1 plus y square. Substitute it as u, then differentiate this u, you will get it to be 2y dy. Okay, now this 2y dy is basically du, so you can write it as integration of root u du can be written as u to the power 3 by 2 upon 3 into 2, which comes out to be 2 by 3rd into 1 plus y square whole to the power 3 by 2, and that's the answer. Initial stages you may find that integration of substitution is very difficult. Well, you do not need to know integration of substitution in that detail because it's not much used in physics. Even if they ask about integration by substitution, they will be giving you some hints or some related formulas. Okay, so nothing to be much scared about that. But still, for practice, you can take another problem. Take another problem like integration of 2z dz into z square plus 1 whole to the power 1 by third. You can take it as a homework and try, but I am also saying you the answer. The answer will come out to be z square plus 1 whole to the power 2 by third plus c. Okay, so now I will be sharing you few problems also in the next lecture, and in the next lecture I will be talking about definite integration and application of integration for kinematics and in our daily life. Okay, before quitting the lecture, I have said you about the integration of uv dx, where u and v are a function of x. Okay, I must have said it to be integration of u integral v dx minus integral of u dash integral v dx whole dx. Right, let us take a function integration of ln x dx. Previously, which I discussed, was integration of 1 by x comes out to be ln x. Now we are doing the integration of ln x itself. How can I do? We visualize it like integration of 1 into ln x and putting u as a function of x to be ln x and v as a function of x to be 1. This vx is a constant and ux is a variable function. So putting forward like that, we'll get it to be ln x into integration of 1 dx minus integration of what is the differentiation of ln x? It comes out to be 1 by x into integration of 1 dx whole dx. Coming back, I said you while doing the product rule that when we discuss about this integration, we do not put the constant c. So we just multiply with only x minus integration of 1 by x, and here also the same, we do not add the constant c while doing the integration. We do it like this into x dx. Finally, we will get the result x ln x minus x, and in the final step we can put a constant c. Okay, so I can say that integration of ln x dx is equals to x into ln x minus 1 plus c, and that's the answer. Hope you get it. Well, this is also a formula you do not need to memorize, but I showed you a method to do integration by parts or integration of two function in multiplication. Okay, we generally take a suitable function to be differentiated and then another function to be integrated suitably. Okay, So that's it for today. In the next lecture, I said that I will be discussing about definite integration and steps of application of integrals. So stay tuned. Have a nice day.